last lecture we were talking about the Quine-McCluskey method for minimizing switching expressions. If you recall, the basic idea was that we were considering the binary representation for the minterms, then using a set of systematic rules we were combining adjacent minterms which were differing in index value of 1, that means number of ones, and we were ultimately creating smaller and smaller terms, and finally, whatever we were left with, those were the so called prime implicants. So, what we have seen so far is how we can get all the prime implicants of a given function. So, let us continue from that point onwards. So, this will be the part 2 of our lecture, minimization using tabular method. So, as I said, so what we have seen in the last lecture is we have looked at a method to generate the set of all prime implicants for a given function, right. So, we had used a tabular method, a systematic method to do that. But what after that? Once we get the prime implicant, what is our next step? So, our next step will be to select the smallest set of prime implicants that will cover all the true minterms of the function. This is very similar to what we were doing using the Carnot map method also. There, starting with the prime implicants which were the so called cubes that we were forming on the K map, we were selecting a minimum set of cubes that will be covering all the true minterms or the ones in the map. Exactly the same thing we were trying to do here. Now that we have got the list of all prime implicants, let us try to see what is the best set of prime implicants we can select out of that, which will be covering all the true minterms of the function. Okay. Now, for doing this, again we shall be using a tabular method, and the table that we will be using now is called a prime implicant chart. Let us see what a prime implicant chart looks like. So, a prime implicant chart essentially is a tabular kind of a structure. So, basically it is a table kind of a thing. So, along the rows we list the prime implicants. So, all the prime implicants are listed along the rows, and along the columns we list all the true minterms. So, which prime implicant is covering which minterm, that we indicate by putting a cross mark. This is how the table looks like. So, let us see what is mentioned here. This pictorially depicts the covering relationship, that means which prime implicant covers which true minterms. Okay. So, as I said, minterms are listed along the columns and the prime implicants are listed along the rows. We shall see some examples, and we will be entering some check marks, some x kind of a check mark in the table whenever a particular prime implicant is covering some minterm. So, we will put a x in the corresponding location. So, what we say is that a row of the table, that means a minterm, covers all the prime implicants, that means the columns, all the minterms, all the minterms, the columns where there are x. Say for example, for some prime implicant we see in the table that there is an x here, there is a x here, there is a x here. So, the corresponding true minterms, these three minterms are covered by this prime implicant, right. This is the idea, we use this term cover. Okay. And the other point to note is that if we see that in the table, let us say we have again the table, there is some prime implicant where we see, or there are several prime implicants, okay. Several prime implicants are there, and you see that in some column there is a single x. For example, in some column, let us say this column, there is a single x maybe in the middle one. What does this mean? This means this particular min term corresponding to this column is covered by only this prime implicant, not the others. So, I must select this prime implicant, otherwise this column will not get selected, not get covered. So, such prime implicant which corresponds to a x which is the only x in a column is called essential prime implicant. That is what I must include in any minimal set of prime implicants that we generate. So, what we have to do finally? We will have to select a minimal subset of the prime implicant, that is what I mentioned. But what is the requirement? Requirement is that every column, which means the true min terms, will contain at least one check mark corresponding to the selected subset, which means what I mean to say is that suppose this is a table, there are many prime implicants. Suppose I finally select this one and this one. So, what I say is that the check marks should be such that these 3 prime implicants will be covering all the columns, that means all the true min terms, and we will have to select this set of prime implicants in such a way that the total number of literals in this prime implicant is as small as possible. As small as possible means the gate realization will be as simple as possible. Let us say one prime implicant may correspond to x z, some other may correspond to x bar y z. So, if given a choice, we will select this, because this contains smaller number of literals. So, this will be requiring a 2 input gate, but this will be requiring a 3 input gate. Okay? Fine. Let us take an example now. Here we are showing a prime implicant chart, just an example of prime implicant chart, where I am showing 4 prime implicants which I have called A, B, C and D. Just ignore these check marks for the time being, and there are 10 true min terms 0, 1, 2, 5, 7, 8, 9, 10, 13, 15. So, this is actually a 4 variable function. This is a 4 variable function, and these are the check marks which says that this x bar y bar, this prime implicant covers 0, 1, 8 and 9. This can also be reflected from the Carnot map. If you for example, draw the Carnot map, let us say if I have a Carnot map like this, where I have x y along this direction and let us say w z along this direction. So, we will be having 0 0, 0 1, 1 1 and 1 0, here again 0 0, 0 1, 1 1 and 1 0. So, this x bar y bar will be corresponding to this cube, this whole row, right. So, if you see, so what this corresponds to? This corresponds to these 4 0, 1, 8 and 9. So, depending on in which order these are mentioned, of course, I have put it in a different order, it should actually be w x and y z. If you put it w x and y z, then it will be 0, 1, 8 and 9. This you can check. Okay? Fine. So, in the same way, for all the different 4 prime implicants, we list which are the true min terms which are covered. Then we look at which of the columns have a single check mark. So, I can see column number 2 here, there is a single check mark, column number 7 also, this 10 also and 15 also. So, these are the only check marks in the column, which means that the corresponding prime implicants are essential. So, I must select B and D. Of course, there is a choice A and C, that is not essential because there are multiple cross marks. Now, see, Once we have selected B and D, so all the check marks corresponding to B and D will get covered. B has a cross mark here, a cross mark here, a cross mark here, a cross mark here. D has a cross mark here, here, here and here. So, what are the columns which are still remaining? 1 is remaining, 9 is remaining, these two, right. Now, in order to cover 1 and 9, I have a choice. I can either use A, because A covers 1 as well as 9, or I can use C. C also covers 1 as well as 9. So, I will have to choose B, I will have to choose D, then I will be choosing A or C. This is a choice, right. This is a choice that we have. This is exactly what we mentioned. B and D are the essential prime implicants. These we must choose. In addition, we can choose either A or C, because this 1 and 9, these two min terms are left out. Both A and C are covering them. Okay. This is how we can get this set of prime implicants which can be covered. So, in this example, as I said, there are two minimal expressions possible. B and D are mandatory. So, this corresponds to B, this corresponds to D. So, here also I have B, here also I have D, and I can include either A or I can include C. So, there are two possible minimum expressions for this particular function. Okay. This is how we proceed with the tabular method. Step 1, we create all the prime implicants of the function. Step 2, we create the prime implicant chart and try to select a subset of prime implicants which covers all the true min terms. Now, there are some tricks here which can help us in minimizing or in selecting the set of prime implicants. We shall be looking at some of these rules now. Okay, first let us see that we can have do not care combinations in a function. Now, we have seen earlier, when you have do not care combinations, we include the do not care combinations in the first step when we are generating the prime implicants, because prime implicants can also include the do not cares. Okay. But when we create the prime implicant chart, we need not include the do not care in the columns. Why? Because it is not necessary to cover all the do not care min terms by the set of prime implicants that we choose. That is why we do not show the do not care min terms in the columns, because they need not be covered. We only show the essential min terms, the ones in the function in the columns which must be covered by the set of prime implicants. Okay. Let us take an example here. Well, here I am just showing a prime implicant chart where you see there are 8 prime implicants which have already been generated, let us say, in the first step. Now, these horizontal lines indicate the size of the min terms. The first one is the smallest, 2 literals, second one is 3 literals, remaining all 4 literals. So, the corresponding function here is this. So, we have used this do not care literals also to generate all the prime implicants, but when you list in the columns, we only list these, but not the do not care ones, right. Now, let us see which of the prime implicants are essential. Look at the columns where you have a single one, we have a single one here, we have a single one here, we have a single one here and also here, these 4 circled ones. So, correspondingly A is essential, B is essential and also D is essential. Now, once we have selected the essential ones, you see A covers 17, 19, 21, 23, 25, 27, 29, 31, many of them. B covers 13, 15, 29, 31 is already covered, and D covers 20 and 21, 21 is covered 20. So, what we are left out here is only 18. So, only min term 18 is not covered. So, after we select A, B, D, in order to cover min term 18, we have a choice. There are two cross marks, either we can use E or you can use G. Since both of them are having the same number of literals, their cost is the same. So, here we will be choosing A, B and D essentially, and either E or G, right. This will be our final selection in this example. Okay. Let us take another example. So, here is the here you show a similar table. Here the essential cross mark, that means single cross marks are here, here and here, which means A is essential, C is essential, these two are essential. Because A is essential, we have a tick mark here, here, here and here, and because C is essential, we have a tick mark here, here, 19 and 23. So, what we are left out with? We are left out with 0, 1, 4, 20 and 22, and also these 5. So, in the earlier example we had only 1. So, just by looking at we could take a decision that which one to select, but in general for a larger table there can be many such true min terms which are still left out. So, now we have to find out. So, out of the remaining min terms which are not out of the remaining prime implicants which are not essential, what is the minimum set I have to select to cover 0, 1, 4, 20 and 22. So, the procedure is we first create a reduced prime implicant chart. So, what is this? So, the columns which have been covered are deleted, only this 0, 1, 4, 20 and 22 are left. So, you only list these, you only list these 5, and A or C have already been taken up. So, the remaining prime implicants are listed in the columns. So, now you have a choice here. You see these remaining min terms can be covered by D, E, F, G, H, I in this way, this check marks. Now, we can very easily find out what is the minimum set of these prime implicants that we cover all of them. How do we do it? We try to determine a condition for selection, and the condition for selection is determined in the following way. Let us look at this min term 0. 0 is covered by either H or by I write H or I. 1 is covered by either G or I write G or I. 4 is covered by F or H, I write F or H. 20 is covered by E or F, I write E or F, and 22 is covered by D or E, I write D or E. So, if I expand using multiplication rule of switching algebra, I get an expression like this. So, I can use any one of these product terms to realize my function, because I have to make this true. If this denote the function f, I have to make f equal to 1. To make f equal to 1, I can make any one of these product terms equal to 1. Last one will be expensive, there are 4 terms. Let us take EHI for example. So, we will be selecting E, we will be selecting H, we will be selecting I. There are other alternatives, we can select EFI, DFI, EGH. So, our choice will be A and C, and let us say EHI. So, we will be selecting these 5, right. This is how we do it. Let us take another example. This is a slightly bigger example, where you see there are 4, 5, 6, 7, 8, 9, 10, 11 prime implicants, and these circled ones are the essential columns. So, the corresponding essential prime implicants are A, B and J, and finally, here K. So, it covers A covers 4, 5, 6, 7, 20, 21, 22, 23. B covers 4, 5, 6, 7, 12, 13, 14, 15, that is it. J covers 1, 3, 5 is covered, 7 is covered, that is it, and K covers 25 and 27. So, what you are left out with? You are left out with 10, 11, 18, 19 and 26, these 5, right. Now, we present some simple rules using which you can further reduce the size of the table. There is a concept of domination. A row can dominate another row, a column can dominate another column. So, what is the basic concept of row domination? It says a row U of the table will dominate a row V if U covers every column covered by V. For example, in row U, I have a check mark here, I have a check mark here, I have a check mark here, I have a check mark here. And in V, let us suppose there is a check mark here and there is a check mark here. So, we say U dominates V, because wherever V has a check mark, U also has a check mark. So, in such case what you do? You can delete V from the chart, because the idea is if we select U, these two columns automatically will get selected. So, we do not need to keep V. So, V can be deleted from the chart. This is row domination rule. So, that same example that you saw earlier, 10, 11, 18, 19, 16 were remaining, and these were the remaining prime implicants, 7 of them. Now, if you use row domination, you see D is getting dominated by C, because C has check mark here, D has a. So, D you can delete. Similarly, F is dominated by E, check mark, E also has. So, F also can be deleted. H is dominated by C and also G, H has a single check mark, H can be deleted. Similarly, I is dominated by E as well as G, I can also be deleted. So, you are left with only C, E and G. So, idea is that you make your table smaller and then you do the next step. So, instead of using a large table, you minimize the size of the table. So, it becomes easier for you. You see, in the minimized table you can immediately see now there is a single check mark in column here and here. So, C will be essential, E will be essential. So, if you take these two, all the columns are getting covered. So, C and E, right. So, in the earlier previous slide we had selected we had selected A, B, J and K, and here we are selecting C and E in addition. This is how we get our final solution. Now, there is a similar rule for dominating columns. Dominating column I am showing with this example. It says a column will dominate another column, like suppose I have a column C1, I have a column C2. If C1 will dominate C2, if C1 has a cross in every row where C2 has a cross. That means, if I have let us say cross here, here and here, and C2 has a cross here and here, then I say C1 dominates C2. But for column domination the rule is different. The column which dominates, that can be deleted, because you see the idea is that if we can cover column C2 say either by this prime implicant or this prime implicant. So, automatically C1 will also get covered. So, if I cover C2, that will imply that C1 also gets covered. That is why the dominating column C1 can be deleted here, right. So, columns, so here in this example, you take this example here, column 11 can be deleted. This is column 11, you see column 11 dominates column 10, okay. That is why column 11 can be deleted. Similarly, column 19 dominates column 18. So, column 19 can also be deleted. So, you can also reduce the size of the table in terms of column. So, the idea is that when you have this prime implicant chart, you first select the essential prime implicants, take them out, your size of the table reduces, then use row dominance and column dominance rule to further reduce the size of the table, then try to find out what will be the set of min terms, set of prime implicants that will cover all the min terms. This is the basic idea behind the Quine-McCluskey method. So, with this we come to the end of this lecture. So, we have seen over the last few lectures the different ways to minimize a switching function. Earlier we looked at the algebraic methods, here we talked about the graphical approach, the Carnot map method, and also we talked about a more systematic approach, a Quine-McCluskey method, which can be used even by hand. You can use a function of 7 or 8 variables to create the list of prime implicants and minimize, and I had also said this is much easier to automate. You can write a program for the Quine-McCluskey method in a much easier way as compared to the Carnot map method. Thank you.